Hey guys, and welcome. In this video, we'll be looking at a CAV application. So all the items that we have covered so far can be used in various applications, and we'll have a look at one particular one which is currently a hot topic. So skills learned in this unit can be used for various applications. As you would have found out, because we learned how to do some programming, which can be useful in many contexts, as well as data processing and visualizations. So in this example, what we'll be looking at is doing some simple machine learning. So you probably heard about AI, machine learning, deep learning, those hot keywords. And when it comes to actually using them, nowadays we have a very comprehensive libraries that provide those models to be used on the get-go, right? So let's have a look at using those to see how CAV fits into this picture. You don't have to understand the underlying details using those machine learning models. Rather, what we do is just import them and use what they provide us to do. Okay. To do this, you will need to install the scikit-learn library. So if you don't have one, it's very simple. It's pip install sklearn. The latest version that I have checked was 0.22. So anything near there or newer one should do the trick. Okay. There is this material is from the tutorial summarized in our unit context. Okay, so you can follow step by step, which covers more detailed instructions using different types of models there. Okay, so the very first one is to understand the data set that we are working with. For this task, we'll be using the provided iris file. So you can download this from the quiz server, or you can download it from the link provided here. Okay. And also we'll be using pandas library to store this CSV file. So if you are not familiar with pandas, please go and look at the video on dataset processing. Okay. So if you are familiar with pandas, this code should look quite straightforward. Basically, what we want to do is read the CSV file and attach these names. So these names are actually specific for our iris file. So maybe this should have been an input parameter for this function, but nevertheless, we are assuming that we'll be using this iris file to deal with. Okay, and then we're going to just return the data set. Okay, so we can let's load it up. This skeleton code is provided to you, which imports all the necessary modules and methods. Okay, so please use that. This is to check which version you're using, so this will be useful. So here is the load dataset stuff. So if I run this, yoink. Come on, yay. All right, so once we have this, we now have the dataset file, which contains those values, and I already specified the names for each column as viewed here. Okay, so that's straightforward. So now we can have a look at what is actually inside and trying to understand better about what kind of data set that we're dealing with. So we can look at the head as well. Print dataset.head. Head. Say first 10 rows. It's going to show us 10 rows, and basically they are just numbers, but just to double check that they are actually numbers, we can go dataset.describe. Okay, and this gives us 4 columns, 1, 2, 3, 4, with statistics. So here we have these 4 columns, so we understand that all of the numbers in these columns will be values that we can use. In the pandas video that we covered before, if any of the dataset value is, for example, not a number, and as a result, we will not be able to describe the column in terms of basic statistics. Okay. So yeah, see visualization lecture video for more details using pandas. Okay, so the next item is trying to visualize some contents through graphs and charts. Okay, so we can do visualization, which gives us a better understanding of how, well, what the underlying data structure looks like. Okay, so we have covered all of this, so we're just reiterating through and see how we can manage this. So that was the preview, what we already did. So here's the visualization part. First one is boxes and whiskers. So in this particular one, we didn't cover in the visualization video, but we can always create the kind equals box. This will create our box graphs. Okay, what we do is we will comment these for now and run this, visualize. Where's my graph? Here we go. So this one is generated as per the slide, and we can see that we can easily see their basic statistics mapped out into the box plots. So the middle green line is the median, upper quartile, they're maxes, aren't they? Min max. These are the upper quartile, lower quartile, and so forth. Okay, so this gives us a better way of understanding and compare them, essentially. Share X is false, share Y is false, but we can convert them. For example, let's change that to true. Then what we're going to get is, the same values used for the Y values. That means you can easily check exactly whereabouts those data points are relative to each other. Okay, we can also do this for the X-axis, but in this case it doesn't apply, so it's better to keep that as false. Okay, so that's that one. Now let's look at histogram. Okay, run. So data.histogram, you just have to call the hist method, then it's going to automatically generate the histogram for us, and it's going to auto-assign bins as it seems necessary. So we can see that here is all nicely done for us. Similarly, we can say, all right, let's share X equals true and run this again. Okay. So now we can do relative comparison between the charts. So we can see that sepal length is much on the upper side, whereas the petal length is in the middle, whereas the petal width is on the lower end side. Okay. So we can always get these parameters in between to see how they lay out as well. So we can even bring this layout, say, let's give it a go. Layout, by default it was 2-2, so let's change to 4-1 because we have 4 plots. So that means I want 4 rows and single column, so this is what we get. So maybe in addition to this, if we make this into a single X share X, then we can easily see the difference between the distributions. Okay, but nevertheless, we can always control these quite easily. Okay, and the next one is looking at the scatter plot of the data set. And by calling it, what it's going to do is plot the scatter plots against other columns, and on its own, what it's going to show is its histogram. Okay, so this way we can easily see if there are any correlations between columns. So for this one, like a sepal length and petal width, maybe some linear here as well, but some other things are quite generally distributed, so unlikely that there will be any correlations. But maybe this one, and maybe a little bit of these, they might have some correlation as well. Okay, so that's the quick visualization for our data sets. So moving on to the next part is to now, we're going to chuck these into our machine learning models. Okay, so we don't have to keep the visualization. And basically what machine learning models allow us to do is provide predictions. Okay, so what we give is bunch of points, and the machine learning model, as the name states, is going to learn about what this data set represents. So when later we give some other points, it's trying to guess what it is. Okay, so in order to do this, most machine learning models will need to be trained. Okay, for simplicity, we'll be looking at trained machine learning models, but there are untrained models or reinforced learning, and there's lots of learning. But however, that's outside the scope of this unit, so you don't have to worry about that. And to evaluate those machine learning models, what we will do is not use the whole data set that we have, but chop it into pieces and use the small portion for training and the leftover for evaluations. So that's for validating whether our model works accurately or not. Okay? And normally what we do is split it into 80-20, where 80% gets used for training and the other 20% gets used for validation. So this is the code that loads up our data set. Basically, X represents our values and Y is going to represent our labels that are assigned for each row. So if you remember from 0 to 4, this is looking at columns 0 to 4 for all the rows. And this is looking at the fourth indexed column for Y. And if you remember, what was the data set dot head? If you remember, we have 1, 2, 3, 4, 5 columns, and the first 4 columns are the values. So we're chucking all the values into X. So these are our values to be used to train them, and Y is an array that we're going to be used as a label. Okay, basically these are the measurements of these types of iris, and therefore these characteristics should produce this iris setosa, and there's a lot more other styles there. So these what we can use is as our classifier. Okay, so we separate out our classifier in here, and they should have a matching number of rows. Okay, so this is our full data set. And what we need to do is just chuck it into a train test split function associated with scikit-learn. We pass in both X and Y arrays, both the data set and the labels. And then here you can specify what is the test size. So if this is greater than 0.2, basically this 0.2 represents the 20% for using validation. And this random state is just a random seed that can be used by the machine learning models. Okay, so we now have the training data stored in X-train and Y-train, and validation data stored in X validation and Y validation. Okay, so we separate them, the data sets and labels separately for both train and validation. Okay, so if we, here we go, run this, this will produce X train and well, all these parameters. So we can check X train contains all these values that has been split from our the original data, and also the Y train will contain the labels associated with each of those training data. X validation is going to be our points that's going to be used later for testing. So you can see that this is much shorter compared to our X train, because this is 20%. So it should be roughly 1/5 of the original data, similar with the Y validation. Y validation will contain the labels associated with these guys. Okay? So that's setting up the machine learning models, well, preparing the data set for the machine learning models. Next, we need to get the machine learning models. However, they are already implemented for you. So all you have to do is just create the model using some of the functions. So here we're going to be using logistic regression, KNN and SVM. You don't really have to understand what they are, but they are some of the most popularly used machine learning models out there. So we just create them and chuck it into models. And what we need is just to receive those models and store it. Okay, so if we do that, what it's going to do is prepare our data and then prepare our models. So here inside models, we have those models. Okay, models. Models. One is our KNN. It tells me what they are, etc. Okay, so now we can test the accuracies using the code on the next slide. This one. Okay, so this is scaling models, but this code here, this second function, is the one that is using the models to test how good they are. So let's have a look in detail. Actually, let's run it and see what we get. So if we run it, the inputs are the models and our training data. Results will contain this, so might as well just print this out. So if we run this again, get the models. All right, here we go. What it's showing us is these are the models, these are the accuracy, and these are the standard deviation. So if we run it again, 9417, boom. Okay, so these numbers within the computer, it should be the same with the same random value that has been set here, random state. But your numbers may be different to my numbers, but that's okay. That's normally the case. But they should be roughly similar because these models, the way they operate is slightly different. Basically, what's happening here is that cross-validate score, what it means is we chop the input data into small pieces and use a little bit of that for training and the other set for testing. So within this training data that we created, we are chopping this even further to see how good those models perform. Okay, so what it means is we're trying to compare these models without using our test set yet. Okay, so we chop it up, and this is k-fold. Basically, we want to chop it into k pieces, so that's what's happening. And here n split means 10. N split is set to 10. That means we're doing k equals 10. So we're chopping our training set into 10 pieces and using the other 9 to train and use the other remaining one to test. We do this for all combinations of sets you can select. Okay, so we do this 10 times pretty much. Okay, and what we want to get is accuracy, but scoring can have some other values like precision, recall, F1 scores. However, we don't really have to understand that here. Okay, so all we need to do is call a couple of functions that handles these for us, and then we just have to return results. Pretty straightforward. Okay, so here results contain the arrays with different accuracies values, and names contain the models that have been used. Okay. Okay. So this is our linear regression KNN and SVM score. So if you just average these guys, take the mean of it, then we get the values up here that we found. Okay. All right. So output should look like this, and because I am still using the same machine, the numbers are exactly how it's supposed to come out. All right, so once we have those results, probably want to visualize it. For example, let's chuck it into this visualization function. And basically what we're doing is just making it a box plot, our box plot into same one, chuck all the results in there, and labels are our names that we retrieved from here. Okay, and just add some title and then show it. So that's quite easy to do, and by visualizing it, it's very easy to compare in general how well they perform. So here you can see that linear regression has actually one of the performance that was quite low. KNN kind of sits around in the middle, and SVM it's quite squashed at the top. Okay, so we can zoom in here like this, even further. It's just sitting at 1. So it reckons that it's very accurate. That's what it's saying. Okay, so in this, with that aspect, we can move on to our prediction. So as we've seen in this result, the SVM seems to have a good result. So this is one way of comparing different models that fits our data set better. So we will be using SVM for our predictions. So this part is where we examine how good the trained model performs against the validation set. So now we're going to use that model that we created and use our validation set that we created earlier to test how good it is. Okay, so we can now do this and move on to make predictions. So what we are doing here is using our model SVM. We use our training set to train this model, and then we can predict using our validation set. So as you can see, it's just 3 lines of code. Make the model, train it, and make predictions, right? And these are our output of evaluation. We can also visualize this output as well. So if we run this, here we go. This is the result that we get into the shell. Okay. So we roughly get 0.96% accuracy, some matrix, right? And then we get the full details about how good they are, like precision recall F1 score, okay? And also the accuracy and stuff. Okay, but normally just looking at these numbers aren't that useful sometimes. So doing the visualization like this gives us a better a view. Basically, what it's saying is it has slight misinterpretation of the iris versi color, right? So you see that it should have been in the middle section, but some of them have been classified as iris virginica, right? On the other hand, virginica has been categorized quite accurately, as well as the setosa, right? So this means this model is performing pretty good, and we can easily highlight by seeing that the identity values have the highest color, whereas the remaining are very light colored. Okay? So rather than just reading through the numbers, visualization gives us a better look. Okay? So that's it really for implementing machine learning models. So hopefully you can also play around with it, use some different data sets to see what you can find about those data. And don't be scared about getting into AI machine learning. As you see here, many of the hard work has been done for you. You just have to utilize many of the models that are available through those libraries. And Python is one of the best language to do this. So scikit-learn is one of the big libraries that people use for machine learning. But if you like to get into like a deep learning, PyTorch is also another library that gets utilized a lot. Okay, so although not in the scope of this unit, you can even write up simple machine learning applications using the skills learned in this unit, and also be able to visualize them to show the results, not just in text form, but in a graph format that can be interpreted and understood much easier. Okay, so it's just a matter of understanding your data to choose appropriate processing and visualization skills to enhance the data interpretation and presentation. So hopefully this unit has provided you sufficient knowledge in order to handle data and visualize them. All right, so that's pretty much it for this unit. The next couple of videos I will do some reviews and have a look at some exam preparation. All right, see you guys.